Welcome to the lecture on marketing analytics. Marketing is a very important function of business. It is so important that many times business and marketing are considered to be synonymous, but uh, amongst many functions in the business, marketing is one important function. Marketing provides many occasions where analytics can be used. In this lecture, however, we will be seeing only two analytics. These are very important one. One is conjoint analysis and another is analysis for market segmentation. In this lecture, we will be seeing conjoint analysis. Whenever we think of purchasing certain product, we look at various specifications of that product. For example, mobile. We look at what is the weight of mobile, what is the how long the battery provides the charge to when you work with mobile, what is the processor of the mobile, how is the screen of the mobile, and so many. What is the memory? What is how many SIMs can be used into it? Whether there is a whether you can use the stylus pen in that mobile. So many specifications are there. Now, when you think of purchasing mobile, some specification is better in some mobile, and some other specification is better in some mobile. You have Because of that, you have ample lot of variety in mobiles which is provided by different companies. Same is in car, right? You have various specification you look for when you purchase the four-wheeler car, like what is the leg space, whether the gears are automatic, whether how much is the space in the dicky, whether it is running on petrol, diesel, or CNG, or it is hybrid. What is the capacity? How many persons can be accommodated into that car? Whether it is four-seater, six-seater, eight-seater, 12-seater, whatever, and what is the price of that car. There are so many other specifications. Now, in the car as well, you will be seeing that you will be seeing that there are number of varieties because of the specifications of the car. You look for one feature in the car, but that is there, but another feature is absent, right? Few features will be present as per your requirement in the car, but one feature may be absent in the car, right? And different person have different requirements of the feature, right? And that's why the cars, mobiles, various services for that matter, insurance. There are various specifications of the insurance. Someone may want some feature in the insurance, and someone else may want some other feature, right? So this is in conjoint analysis, we will be considering all the features jointly, right? And that is why it is called as conjoint analysis, that is considered jointly. Customer preferences are not always explicit. They may say one thing but behave differently. Different customers behave differently. One customer behave differently at different points of time. He wants some feature in the product or service he will be purchasing. He may like few features, but may not like some few other features, one feature, two features, or so, right? So we'll be taking a case. We will try to understand conjoint analysis by taking the case of car. Same thing can be applied to any other product or service. Now let us consider we are thinking of only three specifications. There are many in which the customer will for which the customer will have different choices, right? Like in our case, we will be considering fuel type, petrol, diesel, CNG. Capacity, it may be four-seater, six-seater, eight-seater. The price will be maybe 4 lakh, means low price, medium price, high price, 4 lakh, 8 lakh, 12 lakh. Now, if we consider all the variations of all these three features, so fuel has three features, capacity has three features, price again depending upon the other features, the price is also set. Like for example, the lower end price might be 4 lakh, and high end price could be 12 lakh, and in middle there is 8 lakh price. So you may have petrol four-seater with 4 lakh, right? You may have diesel four-seater, maybe 4 lakh, 8 lakh, or whatever combinations. If you consider all possible combinations of the types of car, you will get 3 into 3 into 3, 27 combinations. But when you look at various products, you will not see all the features are combined in 27 different to get 27 different products. Like for example, you may not have a diesel car with having four-seater and costing 4 lakh. You may not have CNG car running on CNG fuel with capacity four seats and costing 4 lakh. Okay, it may cost 8 lakh, right? So some combinations do not exist in the product or service, even though specification wise you have collected that there are three fuel types, three capacities, and three prices. So multiplying this all 3 into 3 into 3 will give you number of possible combinations to 27, but all 27 combinations will not exist. So with other products, so with other services, right? Now, why not show all 27 profiles? We will not be having 27 profiles, right? And having, suppose say some company produce all the such 27 profiles. I am taking very small examples wherein just I have considered three features, three specification. One is fuel, and one is capacity, and third one is not a feature, but we can consider it as something based on which the customer make his decision. Okay, so company also will not be making 27 product, and even if it makes such 27 product, we will not be collecting the information from the customer for all these 27 product. Okay, instead we use orthogonal design, right? We will sometime be looking in the details of orthogonal design. For now, you just understand it as a statistical design, ensuring no correlations amongst attributes, right? Each respondent rates only 9 profiles. Okay, say there exist 9 profiles only, right? So we have 60 respondents. It is your choice to decide how many respondents will be there, right? So it is your choice to take the number of respondents, right? In our case, we are considering 60 respondents. This is, however, a hypothetical case, fabricated one, just to make you understand how the conjoint analysis is done and how helpful that analysis is going to be, right? Now that there are 9 profiles we are considering, profile means what is the fuel, what is the capacity, and what is the price. Such 9 combinations are there. So in all, when we are asking the rating, we are asking the respondents to give the ratings. He will be giving the rating for all the 9 profiles, right? So 9 into 60 respondents, 9 profiles into 60 respondents, we will have 540 rows of data, right? So here in here I'm showing you the sample of the data. I have the data in Excel sheet, right? That I'll be coming to, right? Now, respondent one, let's look at certain profile, diesel, capacity 8-seater, price 8 lakh, and the rating given to one of the respondent is 9. Another respondent may not give the same rating to this profile. Okay, to another profile, diesel, fuel is diesel, capacity 4-seater, price 4-seater, the rating is 9, and so on. Okay, all such 540 records you will find in the Excel sheet, right? Every respondent is asked to give his rating to various profiles. So different respondents give different rating to different profiles depending upon their preferences, their choices for the profile. Now there is another system like in whenever one is asked to give the rating, and he is asked to give the score between 1 to 10, and if he is asked to rank, he is asked to rank, then it is the order of preference, right? and it is exactly reverse of the rating. In rating, higher is the better. In ranking, lower is better. It is order preference, need conversion to rating or via reverse coding. For example, rank 1 means rating 9, rank 2 means rating 9 or 10, it depends on you. Okay, rating 2 will mean, rank 2 will mean, if you are taking maximum value as 10, then the rank 2 will mean 9, rank 3 will mean 8. So it is reverse coding, right? So rating and ranking that way are not different things. If you want to give the rating, it will be from 1 to 10, 10 being best, and if you want to give the ranking, then it will be again from 1 to 10, 1 being best, right? So I'll be showing you the conjoint data set. Data set means the name of the Excel sheet or the CSV file, comma, separated values file, which opens in Excel, that opens in Notepad as well, but it is prepared for better understanding. We will be seeing it in Excel, right? So conjoined data set, it will be containing 540 rows, right? So let's see the data set, right? Here it is, right? I'll be providing you the data set as well. Now here you see that you have the respondents from 1 uh, to respondents from 1 to 16, 1 to 60, and you see how many records are there. Serial number is signifying you the record number. Your records are going to how much? See here, last record is 540, and each respondent is giving the rating to 9 different profiles: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and for 2 again 9, for 3 again 9, such this way for 60 again 9, 60 into 9, 540. Now each profile, for the profile, like first profile is diesel with vehicle with fuel diesel, capacity 8-seater and price is 4 lakh. Okay, here also some profile you may find diesel 8-seater and price 4 lakh. This respondent 2 is giving the rating of 10. Okay, some other respondent may give lower rating to that profile. So for different profile, different ratings have been given by the respondents. Okay, now this data set, we are writing, we are presenting it differently. Differently in the sense, what I'll be doing, different constituents of the profile, like there are three, not constituents, different specifications, different values of particular specification, like for example, fuel. In fuel, you have diesel, you have petrol, you have CNG. For each of these, I'll be making three columns. Okay, diesel fuel, petrol fuel, and CNG, right? Fuel, diesel fuel, petrol fuel, CNG. And now on the capacity side, we have three types of capacity: capacity 4, capacity 6, and capacity 8. So I am having three columns for that capacity. Just a minute. Capacity 4, capacity 6, and capacity 8, right? You are seeing, and now there are three values as far as price are concerned. Price is 4 lakh, 6, 4 lakh, 8 lakh, 12 lakh. So I have price 4, price 8, price 12. So what I'm doing, I now have 12. I now have how many columns? 3 plus 3 plus 3, 9 columns for different values of the specification, right? Here respondent number is still same, 11111, 9 times, 2222, 9 times, and so on. Now what I am doing, if the vehicle here is having fuel as diesel, what I'll be doing here, I'll be writing 1 in the column of diesel and 00 in the column of petrol and CNG. Now as far as capacity is concerned, it is 8-seater. So capacity 8 column, in the column of capacity 8, I'll be writing 1, and capacity 4 and 6, I'll be writing 0. This all is done by using Excel formula. You may just see here, as per the Excel formula is concerned, sorry, formula is not written here, but you can very simply write the formula in a way, like if Here you may write if uh, C uh, if C1 is equal to C2 is equal to diesel, then 1, otherwise 0. Okay, that kind of formula is there, and with that formula here you will get 1. That can be done easily. You can then drag it down, drag it side, right? And change the formula according to the column you are needing to have the value. Okay, but now that you have understood in what way we are writing the values here, you can write these values by using the formula, Excel formula. Okay, now as far as the price is concerned, price, if it is 4 lakh, in the column of price 4 I'll be writing 1, and when it is 4 lakh it cannot be 8 lakh, it cannot be 12 lakh, so there will be 0. Okay, so you can very easily convert this table to this table wherein all the values will be either 1 or 0. Okay, why we need to convert this table to this one? Because all the variables I am having here in this table are categorical. Okay, you will be having fuel of type diesel, CNG, or petrol. This is categorical variable. Capacity is 4, 8, and 4, 6, and 8 seater. That is again categorical, and the price again is categorical. Price will be 4 lakh, 8 lakh, or 12 lakh. So whenever your data is categorical, then it is better for you to consider the data, explode the data in various category columns. Okay, like fuel diesel, fuel petrol, fuel CNG, and so on. Okay, all the categories, and in the column of each category, if that category is here, you write 1, and if it is not there, whatever is here in the column header, if it is not there, you write 0. Very simple. Okay, now your ratings again are going to be same. Okay, now what you will be doing now, you will be setting certain standard. Okay, standard or baseline vehicle. Baseline vehicle means I may think of a baseline vehicle as the vehicle with diesel fuel and capacity 8 seater and price 12 lakh. This I may consider as a baseline vehicle. Once again, I repeat, fuel, diesel, capacity 8 seater, and price 12 lakh. You may consider some other composition as a baseline. I have considered my baseline composition or reference composition as what? My baseline composition or reference composition as diesel fuel, then capacity 8 seater, and price 12 lakh, right? So what I do for when I consider this as my reference, what I'll be doing, I'll be eliminating the columns, I'll be removing the columns for diesel, 8 seater. Like, see, I don't have the column for diesel. I have, however, the column for CNG and petrol. My capacity, baseline capacity, I have considered 8 seater. So I'll be removing the column for 8 seaters from this. Okay, capacity is 4 seater and capacity 6 seater. I don't have capacity 8 seater. Now in baseline composition, I have the price 12 lakh. So I have removed the column for 12 lakh. Okay, now the number of columns I have reduced from 9 to 6. And as I don't have the column for diesel, 8 seater and price 12 lakh, what does that mean? The coefficient, if I at all make the model, linear regression model, uh, how to make that linear regression model, I'll shortly be telling you, right? Though you will get the coefficients to fuel petrol, fuel CNG, capacity 4, capacity 6, price 4, and price 8. They will get the coefficients in the linear regression model, and as diesel, diesel and fuel diesel and the capacity 8 seater and the price 12 lakh is not obtained, you can consider their presence with coefficient 0, right? So you have understood again. In this is something on which this is something which we will be using for finding the linear regression model. Again, this I have 540 data points, data sets, right? So I will be giving all this data set to my linear regression model. Now, how to do linear regression in Excel? So in Excel, if you go to data, okay, and you go to solver, right? In no, not solver as such. Let me see. Let's go to data analysis, not solver. You go to data analysis. From data analysis, you choose regression. Okay, regression analysis means finding, it is mostly linear regression we do, and doing linear regression means that you will be finding the equation, linear equation between the inputs and outputs. Our inputs are fuel, petrol, fuel, CNG, even fuel diesel is there, but it is not being seen in the linear regression model because it has coefficient zero, and it has vanished because of coefficient zero. Okay, then another input variable is capacity 4, capacity 6, capacity 8 is not there, or it is vanished because of coefficient 0. We have eliminated it actually. Then price 4, price 8, and price 12. We have eliminated the column for price 12. Okay, these are inputs and rating is output. We want to find the relationship between all these input variables. Respondent is not input, right? We are just writing it. Okay, because by changing the respondent number, we are not, it is not going to affect the rating. And nor we want the respondent as input variable. Our input variables will be this six in the columns of u, v, w, x, y, z, right? These are inputs, and your output is in column a, right? And you will be selecting regression. You will be clicking OK there. Okay, let me just click here, and then you will be getting this kind of interface in here, output y range. You will be giving the range from AA2 to AA541, right? And the input range will be from U1, sorry, U2 to Z541, right? And you want the labels. Your data has labels in the top column, right? So in that case, you will be giving your input range from AA1 to AA541, and output range as U1 to U5 Z541. And when you click label, the first row is understood as being the labels. Okay, which will be displayed in your linear regression model. All right. And then mostly you will be clicking OK. You may explore other options as well, but that is not our concern right now. We just want the equation. Okay, so just see, I am getting the equation. What I am getting the coefficients for various variables. I am getting the relative weight to various variables, and that weight is going to be important in further analysis. Now just look here. This, because I have already done that, so I will not be going taking this regression model and filling up all that to take the things ahead. Okay, so when I click OK, I'll be getting many other things, but the thing which is important to us is the equation of the line, which is in the form y is equal to a0 means intercept plus a1 x1 plus a2 x2 plus a3 x3, so on up till a7 x7, right? Now, the coefficients of A1, A2, A3 to up till A7 are given here. A1 stands for fuel petrol, A2 stands for fuel CNG, A3 stands for capacity 4, A4 stands for capacity 6, A5 stands for price 4, and A6 stands for price 8. I by mistake used said that I'll be having the coefficients till A7, but actually they are from A0 to A6 only, right? And these are the coefficients which I have obtained by running the linear regression model. Like, so, what I'll be doing now, now that we have the coefficients for different variables, categorical variables, like fuel petrol, it is minus 1.815, fuel CNG minus 3.86, capacity 4 minus 3.7, capacity minus 6 1.78, price 4 2.64, and price 8 1.82. The baseline categorical variables like fuel diesel, capacity 8, and price 12 will have their value 0 because their columns we have eliminated. These are nothing but the coefficients to multiply to the values in these corresponding columns, which you see here. Okay, now by using these coefficients and these values, the adding the multiplication of these coefficients and the corresponding value here, we will be getting the computed rating. Just see how. For example, the equation of the linear regression model is a0 plus a1 x1 plus a2 x2 so on up till a6 x6 in our case, right? So what we will be doing, our intercept or the constant is 7.94 plus minus 1.81 into value in the value in fuel petrol column, then the coefficient of fuel CNG minus 3.86 into value in fuel CNG column, and then capacity minus 4 coefficient is minus 3.70, it's multiplied by capacity capacity 4, then capacity 6, the coefficient is minus 1.78, that will be multiplied by capacity 6 value in the column of capacity 6, then price 4 and price 8, their coefficients are here 2.64 and 1.82, they will be correspondingly multiplied by 1 and 0 and added to get you the computed rating. So by referring to values in the second column multiplied by corresponding coefficients, summing it and adding to it 7.94 will get you this value. This way you get computed rating. Now that you get computed rating, you will just confirm that whether the computed rating is matching with actual rating given by the respondents. Okay, and we have found out what is the extent of matching by means of coefficient of correlation, which comes out to be minus 0.94. Okay, the best value of coefficient of correlation is 1, right? So in our case we are getting it minus 0.94, higher the better correlation, right? So we are getting the better computed rating. Means even if I have the new profile and I multiply new profile converted to this format, and if I multiply with this coefficient and add to it the intercept, I'll be getting the rating for profile. I need not ask now to the respondent. Okay, that is the power of linear regression. But this will work only if the correlation between the actual rating and the computed rating is very good. In our case, it is 0.94 and considered to be very good correlation, right? Now, for our reference and further discussion, in terms of conjoint analysis, we will be copying these values in our Excel sheet. We will be copying just one decimal or two decimals value. The further letter decimals we will be ignoring. And now let's come to PowerPoint. Right here, I have the values, means categorical variables whose name uh, is written here in this column. Then intercept, fuel petrol, fuel CNG, 4-seater, 6-seater, price 4 and price 8. This is just representative of that, right? The coefficients are same as those were in the Excel sheet, just the latter decimal values are truncated. Now, intercept 7.9 means what? That baseline utility value. It is baseline utility value. What is our baseline? The car with diesel having 8 seats and price 12 lakh, the utility of that car to the respondent or in general, user in general, is going to be 8, right? Good utility, right? And suppose say one replaces diesel with petrol, then the utility falls down to minus 1.8, and if the diesel is replaced by CNG, the utility drops further to minus 3.9. Okay, so there is a strong dislike for CNG as compared to diesel. Petrol is slightly less preferred than diesel. Okay, and diesel, as you are seeing, that the utility is better, right? Then, as far as number of seats are concerned, well, 8-seater vehicle is most preferred. Then next preferred is means next less preferred is 6-seater. Okay, so utility value falls down by 1.8, and if someone goes for 4-seater car, then the utility as compared to 8-seater will be down by 3.7. Now, obviously, less money, less cost is more preferred, right? 8 lakh worth car will have 1.8 more utility than the diesel car, 12 lakh car, and 4 lakh car will have 2.6 um, 2.6 better utility, utility worth 2.6 will be better as compared to the diesel, as compared to the car costing 12 lakhs, right? uh, Here, we in this example has got the r square value 0.94. This is fabricated data set. In the real world, the r square value one get is much less. Mhm. Here it is written zero point 0.3 to zero point 0.5, but it is more than that, right? So that we can carry out conjoint analysis um, on the data collected from the respondents, right? Now, I'm going to attribute importance. Uh, Importance is measured as the range of coefficient per attribute. For example, fuel. Fuel ranges, like I have the fuel ranging from 0 to minus 3.9. Actually, I am taking the absolute value. 0 is the utility value for diesel because it is not present here, and we are considering it as a reference. Reference is 0. Okay, so the range for fuel is 0 to 3.9, rather minus 3.9. Then capacity ranges to 3.7, 0 to 3.7, right? 0 is the utility value assigned to or obtained for 8 seater, and 3.7 is the worst. So the range of coefficient per attribute for capacity is it 0 to minus 3.7, and price it is 0 to 2.6. And if I add them all and divide by the sum to each of the value, I will be getting the relative importance. The sum, for example, comes here 3.9 plus 3.7. It is coming out to be 7.6 plus 10.2. The sum comes 10.2. So 3.9 divided by 10.2, you will be getting it 0.38. 3.7 divided by 10.2, you will be getting it 37 or 0.37, and 2.6 divided by 10.8 gets you 0.25. And in percentages, the relative importance you are getting for fuel, it is 38%. People give more weight to fuel. Decisions will be made better based on, most of the respondents will be taking the decision based upon the fuel type, then the capacity of the vehicle, and to price the customers are little less sensitive as compared to fuel and capacity. Customers care most about fuel type and followed by capacity, then price. Then coming on to the application of conjoint analysis. Suppose say the customer shifts from 8 to 6 seater. Okay, the utility will be lowering by 8 to 6 seater. Okay, 8 seater, the utility we are considering as the reference 0, and he switches to 6 seater, the utility will lower by 1.8. That's what we will be getting from this value. To compensate, because the utility has reduced, you will have to reduce the price as well. Okay, from 12 lakh to 8 lakh, the price increases by 1.8 as you are seeing here. Okay, even though this is hypothetical data, but good enough for making this kind of analysis. So the utility which was lowered because of sacrificing the number of seats from 8 to 6 has been compensated by the price drop from 12 lakh to 8 lakh. Okay, so this kind of decisions can be better taken at the marketing executive level. Okay, this analysis customer may not do, because for that customer needs to have the data collected from various respondents. So marketing research people will be doing this kind of analysis, and that will help them settling their prices. Okay, now the for getting certain more leverage on the count of price, they may reduce the price even further so that the customer has the feeling of getting more utility. Okay, thus the cut from thus a price cut from 12 to 8 lakh compensate for smaller capacity, right? Then willingness to pay, WTP. Instead of asking the rating, we can ask the customers the question like, how much would you pay for this profile? You will be presenting them the profile also. Instead of asking them the rating or the ranking, you can ask them um, to 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 write how much would you pay for this profile. Okay, so then you can run the regression model, regression analysis on monetary value, and you may get the output in terms of willingness to pay per attribute level. For example, for diesel car, the customer may be willing to pay 10,000 more, right? Eight-seater car, 25,000 more, and for 8 lakh price, say 8 lakh price, the best line price. You may set the best line there and carry out a similar kind of analysis, right? So analysis, while doing the conjoint analysis, it is not necessary that your output should be in terms of rating or utility. It could be in terms of monetary value, it could be in terms of ranking, it could be in terms of any variable of your interest, right? Now you can do the product design as well. You can simulate the product design, build a market simulator based upon this information which you are having, all right? Input different combinations and predict the utility and market share. For example, there is a car with petrol 6 seater and 8 lakhs. So what you need to do is petrol means minus 1.8, 6 seater minus 1.8 again. Okay, and the 6 seater is minus 1 point. Sorry. Petrol. It is petrol. For petrol, it is minus 1.8. For 6 seater, minus 1.8, and the price 8 lakh. Okay, price 8 lakh. So if you add this three value, minus 1.8, minus 1.8, plus 1.8, and add it to the baseline cost, that is the cost utility found for diesel vehicle with 8 seater and 12 lakh rupees cost. So 7.9 minus 1.8 minus 1.8 plus 1.8 will get you the utility 6.1 compared with the baseline, which is 7.9, right? Now, if you think of a diesel car, 8 seater and 12 lakh. Okay, it is the best line composition for which the utility is 7.9, and the car C with CNG 4 seater 4 lakh. CNG utility, because of CNG drops down by minus 3.9, drop down from 7.9. So 7.9 minus 3.9, 4 seater minus 3.7, and 4 lakh 2.6. So the result comes out to be 6.3, right? Am I correct? 7.9 minus 3.9 minus 4 seater 3.7. You may correct the result if it is wrong. The result will be 7.9 minus 3.9, that is 4, 4, and for 4 seater it is minus 3.7. The utility drops to zero point 0.3 plus 4 lakh 2.6. So it should be 2.9. Here I have written wrong. It should be 2.9. Very less utility, right? The highest utility product wins more share. Strategic uses. It is used for segmentation. Different group prefer different attributes. Uh, Family prefer 8 seater. Bachelor prefer cheaper price. Competitive analysis you can do. That is test how your product stacks against a rival brand. Then you can decide the price accordingly, right? You can change another features. Feature bundling, see if the customer value fuel efficiency plus lower price together. All these analysis can then be done. Mm, so the file which we have seen, Excel file, has respondent from 1 to 60. Fuels we have considered were diesel, petrol, CNG. Capacity 468, price 4812. Rating we have given is 1 to 10, right? Then coming up, the example was fabricated, right? Then there is a Python code which you may use, right? Then, uh, then this is something I'll read for you. Check the significance of the coefficients. We have checked it. Compute the importance of attributes. Range. We have found out max minus mean coefficient for each attribute. normalize to percentage importance, then use the coefficient to simulate utility to new product profile, then convert the rating into part worth utilities for the conjoint plot. Okay, so we will stop for now. Thank you for uh, listening.